everybody. I'm Elisa. We're back and we're talking about the heart. Uh, Today, or this is tonight, or the next time, I don't know when you're viewing this, that we're talking about the valves of the heart. So these are like the inside doors, mainly of the heart. There's a couple of different ones that we're going to look at. The first group are the semilunar valves. So these are going to be the ones that are going to be flowing from either the pulmonary circuit between the right ventricle and the pulmonary trunk, and then there's the ones for the aorta, which is also between the left ventricle and the aorta. Let's take a look really quick at all the valves. So what happens is, like, you can see that here's a heart, and we took like a slice, we just cut all of these veins and arteries right off the top of the musculature of the heart. And what we see is we see all of the like doorways, right, that control blood flow into and out of the heart and through the heart as well, through the various chambers. And so there's actually some kind of cool features in here that I want to talk about. So first things first is you really have three valves that have like three kind of doors, if you will, that open up, like, I don't know, like three French doors, except in heart shapes forms. Two of which are more internal to the heart proper. Okay, so these are going to be what we call the atrioventricular valves. Sorry, that's like so terrible handwriting. Atrial ventricular valves. And so these ones are going to separate. Here's like the heart, right? Atrium and ventricles, right? So that's what these ones are here. You'll kind of know what they are from any of these types of figures that get thrown at you because of these little chordatinity. Remember these little tendons, the marionette strings that open and close these particular valves, right? They're attached to the papillae, right? Inside of the muscle of the heart, and so they kind of pull open and shut these particular doorways, these particular valves. So there's one that's the bicuspid. Oops, I'll just write it by it. Bicuspid. And it means like a cusp is like this, right? It's like these bumps. So that's like a cusp, right? And so the bicuspid means that there's like kind of two right here, as opposed to the tricuspid valve right here, the right one, which has like three-ish ones, if you can see that. So that's what that's referring to, right? We refer to that lefty as the mitral valve, and the right AV valve is, the right AV valve or the tricuspid valve. So hopefully that's helpful. So these valves here are actually a little bit different. So they, as you can see, they don't have strings. These are exclusively pressure based. And so these are the ones that are going to be going out into either the systemic circuit, there it is, or the pulmonary circuit, right? And so aortic valve, as you can see here, tricuspid, but it's a pressure based and it's slapped shut pretty thick because it has to do with internal and external pressure on either side of the blood vessel. So if it becomes too heavy on this side, it's like going to fill these cusps with blood and they're going to slap shut, right? And if the pressure is higher from below, then that pressure is going to push them open and blood's going to like flow on out and through. So that's typically how they go. So something kind of neat about the aortic valve is like it's where you find there's these little diversion channels, right? And so what these are the diversion channels for the coronary arteries, or the arteries that are going to feed oxygenated blood to the heart. So that's their position, and that is a neat and high pressure, pretty high pressure place to be. And since they're right beyond the valve, that's probably makes sense as to why they're there. It's probably like just enough to get them to like push through and be able to like spread throughout the exterior of the heart and the myocardium and all that good, awesome stuff. Right. Let's see. What do we talk about? Okay. So the fibrous skeleton essentially is just scaffolding, right? Connective tissues like the duct tape of the body, ligaments and tendons and all that good stuff. It just keeps them positional. It also keeps them stabilized as well. So that's the top part. Here's an aortic valve, as you can see here. So you can imagine these little like baskets, except for obviously right here. This little baskets right here, they like the blood pools on this side, right? There's like a ton of blood and it kind of forces it shut. And then you can see these little tiny cracks. So when pressure gets high on this side of the aorta, right? So the ventricle is going to push it out. You can see that it would push these like to the side open. Okay. Tricuspid valve itself. So this is the chordatinity, and so it looks like it's kind of stuck here on the papillary muscle, right? And the papillary means finger, or like finger-like, right? Papilla, right? That's what that means. And so it's that is it. And so this is inside of the ventricle of the heart. And this is trabeculae. So remember, trabecular looks like kind of like that. It's like woven bone. It's spongy looking. That's like the phenotype for trabeculae. So trabeculae carne, which basically just means meat, muscle. Um, so blood flow through the chambers, the ventricles will relax. So the blood pressure is going to drop inside those the ventricles. Sorry. The semilunar valves are going to close as blood tries to back up into the ventricles from the vessels. The AV valves will pop open up, and blood will be flowing from the atria back into the ventricles. So it's like, it's a pressurized system. The atrioventricular valves are going to close after blood backs up into the atria, right? Again, pressure-based system. As the pressure again rises in the ventricles, which is what the ventricles are all about, like extending that blood pressure, and that's why they expand and then they contract and they push blood forward. Semilunar valves are going to open and the blood is going to flow into the great vessels. So that's like aorta and all that good stuff. Um, we'll talk about blood flow in the next talk, but for now, that's some bell stuff, and I hope it was helpful in the inside doors of the heart. Have a lovely day.